Okay, today we're going to look at algebraic proofs, and a proof is just an argument that uses all these different things like definitions and properties and theorems to prove why something is true. And so the important thing that you have to remember here, especially with our algebraic proofs, is you have to justify each step. You can't solve an equation here and do multiple steps in one. You have to show each separate step. So before we get to solving, let's look at our different properties that we're going to use here. So the first one, if A, then A equals A. Well, that's kind of an obvious statement, but sometimes you have to make that statement and say, well, if you have this, you have it everywhere. So if you have A, you know A is going to equal A. This is called your reflexive property. Won't be used much with algebraic proofs, but you will need it as we go along through this unit. Then if you look at the next one, you see if A equals B, then B equals A. There was a flip happening, but it's the same on both sides. It's just a flip, kind of a reflection. And so this is your symmetric property. You'll see an example of that here in a minute. Then the next one, we can see that A is being distributed into the parentheses, so your distributive property. Then the next one, if A equals B and B can be substituted, there's a key word there, for A in any expression, then you're using the substitution property, making that replacement in there. Okay, the next one, if A equals B and B equals C, well, then A has to equal C also. So if A is the same as B and B is the same as C, then we can say that A and C are the same. And so this is called the transitive property. This one reminds me of the phrase cutting out the middleman. See here how B is like a middleman and we cut it out. So that's a phrase you're going to hear me use this unit is cut out the middleman, and that means the transitive property. It takes 3 steps to get the transitive property. A equals B is the first step, B equals C is the second step, and then we get to our conclusion of A equals C as our third step. Okay, the last 4 you're going to see a lot in your algebraic proofs. We can see that in the next one that if A equals B, then we can add C to both sides, and so we see the addition happening on both sides, and so that is your addition property. Notice that C's being added on both sides. That's important to remember. The next one we see C being subtracted on both sides, so that's your subtraction property. The next one, we see C being multiplied on both sides, so your multiplication property. And the last one, we see that C is being divided on both sides, so your division property. So keep these handy so that we can use them as we're working through our proofs. Now, when we work with our proofs, we are going to be using a 2-column format. With algebraic, I could make you fill out both sides. When we're doing the geometric proofs, I will only make you do the right side of the proof. But you're always going to be given a given statement and a proof statement. Given part is like the question, prove is the answer, and why did that answer work is what we're trying to prove here. So let's look at the first example. We have 3x minus 8 equals 19. We're trying to prove that x equals 9. And we can see here that the given statement is always going to be first, and our proof statement will always go at the end. And so we have to justify with steps on how we got x equals 9. So if we look at the first one, we can see that to get 3x plus 27, we added 8 to both sides. So I'm just going to make a little note that we're going to add 8 to both sides. And so that means that we use the addition property to get 3x equals 27. So it takes jumping down a step for your reason. Then to get x equals 9, we can see that we divided both sides by 3. And so to get x equals 9, we use the division property. One thing I never want you to miss on a proof, whether you know how to do it or not, always get your givens in there and write the word given beside it. And what I'm talking about is right here in blue. Write the word given. That's always going to happen, so never miss that part of a proof. Okay, looking at the next one, we're going to have to do both sides. And so first thing we're looking at, we were given this. We're going to solve and prove a justification for each step. There's not a proof here. but we will still get one in the very end. So let's copy down our given statement. And that would be given. We're always going to write given by the given statement. Then let's say, a lot of options here, but let's say just to be consistent, we decide to do move the 3x over. So if we subtract 3x, and again I'm just writing it little just to remind myself what we did, we would get 12 equals 5x minus 18 because we use the subtraction property. Next step would be that we added 18 to both sides. And when we do that, we would get 30 equals 5x because of the addition property. And we would finish with dividing by 5. And so 6 equals x. We would get that because of the division property. Now, we can't end our equation like this. X has to be on the left for us to truly end our equation. So if we go back and flip those and say x equals 6, we just made a flip. All we did was use our symmetric property. And that is done. We started with our given, we found our solution, and we justified each step. Okay, this next one here, we have our given, and they actually gave us two givens. We can see here 1, 2, and they put both of those into our proof. So when they give us a value for our variable, that means they want us to plug it in. So if we take the a and replace it with a 3, we get 3 times b plus 2 equals 45. And since we subbed that 3 in for a, we used our substitution property. Okay, now we're back to just solving a regular equation. We would distribute the 3 next, so we would say 3b plus 6 equals 45 because of the distribution property. So I'll just write distribute to abbreviate. Okay, the next step, we would see that we would want to minus 6 from both sides, and when we do that, we would get 3b equals 39 because of the subtraction property. And the last step here would be to divide by 3, and we would get b equals 13 because of the division property. Okay, last little bit here, just kind of practicing the different properties. So the first one they want us to practice is symmetric. Remember, symmetric is just a flip. So if we know that 3x minus 1 equals 14, then we can flip it and say 14 equals 3x minus 1. The next one they want us to practice is transitive. Remember, transitive is our cutting out the middleman property, so we can see if angle A is congruent to angle x, and angle x is congruent to angle t. Our middleman here is the x's, so we can put those together and say, well, then angle A is also congruent to angle t. And our final practice one is substitution. Remember, substitute is replace. We're just subbing it in. So they want us to sub in the 4 in for BC, so we can write that as 4 plus NP equals BP, and we can see our substitution of the 4 for the BC. And that is all with algebraic.